I'm going to do the notes for 2.2 days 1 and 2 all in one video. So, inductive and deductive reasoning. Inductive reasoning is like when you took these standardized tests, probably in grade school, and they had a pattern like 1, 2, 4, 8, 16, dot, dot, dot. And they said, like, what is the next number, right? What is the next number? And you were looking for a pattern. And so here, hopefully you notice that it was like times 2 each time. It's not always like multiplication. Sometimes it's addition or something else. But if that's the case, then 32 would be the next number. And that's like inductive reasoning. Inductive reasoning is when you look for a pattern. So you're finding a pattern. You're looking for a pattern, and then you write a conjecture. It's almost like a hypothesis, like, I think it's this. And then you test it. So on here it says, describe how to sketch the fourth figure. Well, notice this is in 2 parts. This is in 4, or there's like 2 lines. This has 3 lines, or in 6. If we draw the next one, I'm assuming we would draw 1. This is my conjecture at least. 2, 3, 4 lines. And we make it into 8. So these are kind of fun. We're making guesses and looking for a pattern. SRQP, elemental PQRS. Oh, it looks like it's backwards. Okay, LMNOP. Oh, the next 2 numbers are letters. ON, LMNOPQRS. Okay, so that's my conjecture. 1, 2, 6, 24. This is like +1, +4, plus a whole lot. Maybe it's times because it's getting so big so quickly. So this is times 2, times 3, times 4. I bet the next one is times 5. So I need my calculator. I think it's 120, but I just want to make sure. So 5 times 24. Yep, 120. So 120. Oh, that's the next number. And then times 6 would be 720. So the next 2 answers would be 120 and 720. Okay, so sometimes it says to show that a conjecture is true, you must show that it's true for all cases. You can show a conjecture is false by finding just one counterexample. A counterexample is a specific case when the conjecture is false. So let's say someone makes this statement and they said, the value of x squared is always greater than the value of x. And you might test that. You might say, okay, 2 versus 2 squared, which is 4. Or 1 versus 1 squared. That's not greater, is it? So like 1 and 1, that's not greater. Also, we could do things like 1/2 versus 1/2 squared, which is 1/4. That's not greater either. So we have a couple counter examples. So we could say 1 versus 1 squared. That's a counter example. Or 1/2 versus 1/2 squared. So those are a couple ways to prove that that conjecture is false. The sum of 2 numbers is always greater than their difference. Okay, the sum of 2 numbers is always greater than their difference. So we could do like 2 plus 3 versus 3 minus 2, right? Even if we did 2 minus 3 or 2 minus 3, right? That's 1 or -1, always the same. But we can think critically. Two numbers. It didn't say it had to be two positive numbers. So what if it was like -4 plus 2? Or we'll say it this way. 2 plus -4 versus 2 minus -4. That's 6. That's -2. So the sum wasn't greater than the difference. So we could just say 2 and -4. That's an example, counterexample. All right, day 2, deductive reasoning. So deductive reasoning, so what we did in day 1 is inductive reasoning. Inductive reasoning is finding a pattern. Deductive reasoning is logic. Good logic, right? Concrete logic. This uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. So this is more of what we're going to do in geometry. We're going to use some of those postulates. So far we learned angle addition postulate, segment addition postulate. And we are going to logically go through things. So we're going to learn 2 laws of logic. The first one is the law of detachment. So the law of detachment says if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if it says, okay, so in other words, all right, this is kind of going beyond. But in other words, like if P, then Q, okay? So if P is true, then Q is true. Done. And so then it usually says if, or given P, we'll say given P, we can assume Q. However, if you are given Q, you cannot assume P. And that is, remember our P implies Q only goes one way. Let's look at this example. It says if, oh, I got it. Okay, we're doing one thing at a, okay. So that's the law of detachment. Okay. Yeah, I was confused because they gave both laws at once. So the law of detachment. So that's like this one right here. It says if 2 segments have the same length, so if that's our P, then they're congruent, Q. So that's our P and that's our Q. Now it says you know that BC is equal to XY. So that's saying we're given P. We're given 2 segments have the same length. So it doesn't just like say given 2 segments have the same length. They'll give you like a specific example. But using law of detachment, what can we make? Then we could say BC, segment BC, is congruent to segment XY. And so again, we were given the hypothesis, then we know the conclusion's true. Now, the other law is the law of syllogism. And the law of syllogism is almost like the transitive property. So it's kind of like if P then Q, and then we're also given if Q then R. So if it follows a logical chain of command, in other words, P then Q and Q then R, see how it all lines up in this chain? Q is in between P and R. Then we can assume if P then R, that it goes through that chain of reasoning. We call that a chain of reasoning. So let's look at this example. It says, if possible, use the law of syllogism to write a new conditional statement that follows. So x squared greater than 25, then x squared greater than 20. Now, it says x greater than 5, then x squared greater than 25. So you can see that we could continue from our first one, that we could write this chain of reasoning. If x is greater than 5, then x squared is greater than 25, then x squared is greater than 20. So we could write a new conditional statement that said, if x greater than 5, then x squared greater than 20. Because this whole chain of reasoning is true, we could line it all up, that one follows the other, follows the other. Okay, this one says polygon is regular. Okay, so polygon regular. Then we'll say interior angles congruent. The other one says polygon regular, sides congruent. So you can see we have a repeat first one, but it's like our hypothesis gives us two different conclusions. We can't make that like P, Q, R chain of reasoning. It just, we can't put these together. It's just polygon regular, interior angles congruent, polygon regular, sides congruent. All right, so finally we've got some examples. Decide whether it's inductive or deductive reasoning. Remember, this one is patterns. This one is logic. Okay, so each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. So this is like a pattern, right? You know, like Monica is testing something, right? Every time she kicks the ball up in the air, it returns to the ground. So every time this happens, this is the pattern. So this would be inductive reasoning. Okay. It says all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's parrot is not a reptile. So if Sue's, so this is deductive, because if Sue's has a parrot, parrot means not reptile. And then we know reptiles are cold-blooded. Blooded. So if it's not a reptile, it can't be cold-blooded. So there we go. Okay, so some more practice. If the measure of angle R is between 90 and 180, then R is obtuse. So the measure of R is 155. So if the measure of angle R equals 155, so we have this, right? That's true. So then we can say then angle R is obtuse. And this is, yes, that law of detachment. The law of syllogism, to write a new conditional statement that follows. Okay, get A, then you can go to the movies. If you go to the movie, then you can watch your favorite actor. So notice that we could write this chain of reasoning. Get A means movie, which means favorite actor. So we can say our conditional statement would be, if you get an A on your math test, then you can watch your favorite actor. Finally, decide whether inductive or deductive reasoning is used to make the conclusion. All multiples of 8 are divisible by 4. 64 is a multiple of 8, so 64 is divisible by 4. So this is not a pattern. It's just saying all multiples of 8 are divisible by 4. It's not like, Susie tried whatever so many times, or it's a pattern. So let's see if we can figure this out. Multiple of 8 means divisible by 4. 64 is a multiple of 8. And so you can see we've got 64 multiple of 8 divisible by 4. So it does follow that law of syllogism. And so we can say if a number is 64, it's divisible by 4. We can follow that chain of reasoning here. So it is deductive. And specifically, it's the law of syllogism. And there you go. All of section 2.2, days 1 and 2.